Alright guys, welcome to this page of the notes. Now what we're going to do is we're going to start to take a look at that first objective, solving a system of linear inequalities. And before we do that, I just again want to quickly cover what is the solution. Well, I've got that written out for you right here. It turns out that graphically, oh no, I don't want to slide around, I want my highlighter, there it is. Remember, when you graph an inequality, you are going to be shading the graph. So if you graph multiple inequalities, you'll have several regions that are shaded. And what you're looking for as the solution to the system of inequalities is where does all of that shading overlap, right? Where is the region of overlap when we have done our shading? So to get us started, I really like doing problems like this one right here. For a couple of reasons. First of all, one of the things that can happen with these is in order to solve a system of inequalities, right, you first need to be able to graph functions, which sometimes goes wrong, and it doesn't necessarily mean that you don't know how to do a system of inequalities. It just means you made a mistake with graphing. But of course, if you don't graph the equations right, then you're not going to get the system of inequalities right either. And then you need to be able to shade properly, and errors happen when it comes to shading. So here's what this does. When I give you a graph that looks like this, I give you a system and I ask you which region, region 1, region 2, or region 3 is the solution region. Well, I've already done the graphing for you. I've already done the shading for you. If you understand how a system of inequality problem works, all you need to do is, right, solve the system, figure out which is the region of overlap, and it just, there's less risk of you getting the problem wrong because you make a mistake with graphing and shading, and the only reason you would get this problem wrong is if you just don't understand how to find the solution region of a system of inequalities. So I really like these problems a lot. Let's go ahead and take a look at how this is going to work. First, I need to graph the equations, but I know I've already graphed them for you. Again, it's just helpful. It's good review if I run through all 4 steps. So let me do that for you. Step 1, right, we're going to graph y equals 2x minus 4. Although you don't have to worry about graphing it because I already graphed it for you. Step 2, it is strictly greater than, so I need a dotted line, dotted or dashed, whatever you want to call it. Step 3, my line does not go through 0, 0, so I will choose 0, 0. And then finally, step 4, plug it in and let's see what happens. Okay, here we go. I'm going to have 0. Let's do this. Y is greater than 2x minus 4. Sorry, let me scoot over here so you can see what I'm working on. Y is greater than 2x minus 4. Now, I'm going to plug in zeros. 0 is greater than 2 times 0 minus 4. Fantastic. Keep going. 0 is greater than a negative 4. Question is that a true or false statement? Well, that one's true. Okay. Let's think about this for a second. I need this dotted line. I chose the test point 0, 0, which is right there. Now, that test point gave me a true statement. So if I were to shade the graph, right, what would be shaded? Well, everybody over here on the left-hand side of that dotted line. Which regions are those? Well, that shaded area would be region 1 and region 3. Region 1 and region 3. So let's put that. Region 1 and 3. Region 1 and region 3. If I were to graph this guy and shade, I would get region 1 and region 3. Let's go ahead and do the next one. Here we go. Run through all 4 steps because it's good review. We're going to graph y equals. That's going to be a negative 1/2. I'm not sure why I wrote it as 0.5. Probably just trying to be sneaky, but you should recognize when 0.5 is 1/2. So my rise is a negative 1 and a run of 2. Fantastic. Oh yeah, no, it's not strictly less than, it is less than or equal to, so it is a solid line, 3. Does my line go through 0, 0? It does not, so we will pick 0, 0, and now we plug it in. Step 4, so I have y is less than or equal to negative 1/2 x plus 3, which means 0 is less than or equal to negative 1/2 is 0 plus 3, which means 0 is less than or equal to a positive 3. Wait a second. Holy cow. I apologize. Look at that. I think did I make a mistake? No, I didn't. Sorry. Okay. Sorry. We're good. I did. We're good. 0 is less than or equal to a positive 3. Now, is that a true statement? Well, yeah, that turns out to also be true. Okay, well, my test point was right there. There's my test point. There's my test point. It's the solid line, that guy right there. Since my test point gave me a true statement, where do I shade? Well, it's true, so I would shade the test point side. That's going to be everything below that solid line. Turns out that is the region 2 and 3. So, what is the answer to this question, right? I want you to solve this system of inequalities. What is your solution region? Well, it's whichever one they both have in common. This one has a solution region of 1 and 3. This one was 2 and 3. So which one's our winner? Well, that'd be region 3. Region 3 is the region that both of these inequalities would have in common, right? That's where the shading would overlap if you had done your own shading and you have solved the system of inequalities. I love these problems, they're great, but really what we want to do is get to ones where you've got to do all the work on your own. So let's flip over to the next page and we can go ahead and give one of those a try. So let's see what we've got here. Oh, okay, fine. Actually, I apologize. Let's talk about this real quick. It is possible to get no solution. That is going to happen if the inequalities that you graph, which I've already done for you, so we're not going to work this one out because I already did it for you. You can just look at it, but and I'm sure there'll be one of these later. But if you were to graph them, you get parallel lines. And because the shading goes in opposite directions, there is no region of overlap, and so you have no solution, right? No solution, the empty set, right? You don't have a region of overlap. So here we go. The one that I wanted to do when we got to this page, let's go ahead and do this system of inequalities. I'm going to do this one first, so let me step over here so you can see my work. Let's run through our steps. Step 1. We're going to graph x equals 2. Well, that's easy to do. Anytime you have x equals, it will be a vertical line, and a vertical line at x equals 2. This guy right here. Now, step 2, do I need a solid or dotted line? Since it is greater than or equal to, it will be a solid line, and that solid line will run right straight down through here, like that. Please make sure you extend your line all the way through the graph and put arrows, and put arrows on either side of the line so that I know you know that line just keeps going. All right, step 3. Step 3, I need to choose a test point. My line does not go through, right? My line does not go through 0, 0, so I can pick 0, 0. I am sliding back and forth here like crazy. So this video is hilarious to watch. So there's 0, 0. And step number 4, we plug it in. X is greater than or equal to 2, which means 0 is greater than or equal to 2. Is that a true or a false statement? Well, no. 0 is not greater than or equal to 2. This is false. And since my test point is on the left-hand side of the line, and it was false, I shade everybody on the opposite side. You know what? Here we go, highlighter. I like that. Hopefully you can see that highlighter. Actually, let me go ahead and erase this so that it doesn't get us confused. I'll get rid of that stuff there and then re-highlight it in. That way it is all nice and uniform, because those lines kind of flying around there would look. Okay, there we go. So my highlighted region. Let's do the other one. This is step 1. There we go. We're going to graph y equals 3. Okay, well, anytime you have y equals, this is going to be a horizontal line at whatever the value of y is. Since it's a positive 3, I will have a horizontal line, 1, 2, 3. I just need to figure out, is that line going to be solid or dotted? Since it is strictly greater than, it will be a dotted line. So let's put a dotted line in there. There we go. Make sure you extend that dotted line the entire way through the coordinate plane and put arrows on either end so I know you know that that line just keeps going. Now we need to choose a test point. Well, that dotted line does not go through 0, 0, so that's going to be our winner. And before we plug it in, y is greater than 3 is 0 greater than 3. That is a false. False statement. 0 is not greater than 3. Since my test point is right here, right? It is below, my test point is below the dotted line, and it gave me a false statement. I need to shade everybody above the line. Okay, let's do that. Okay, everybody above the line. Great. Well, what is the region of overlap? Where does the yellow and the green overlap? Well, that overlaps right here. And I have found my solution region, the region where the region where I have that overlap of the yellow and the green. All right, so that takes care of our first example when it comes to graphing a system of inequalities. Head on over to the next page of the notes and we'll try a couple more. I'll meet you there.